problem is find the Fourier transform of f of x and hence evaluate. The problem has two parts. We solve the first part first. So first part is find the Fourier transform of f of x. To solve the first part, we will use the first formula. Okay, so what is the first formula? F of s is equal to minus infinity to infinity f of x e to the power isx dx. Okay, so here the limit is minus infinity to infinity and the function is f of x. Now when we look at the question, f of x has a different limit. Modulus of x less than a, modulus of x greater than a. So first I will do some analysis with the limit. Okay, so here the first part is modulus of x less than a. The second part is modulus of x greater than a. So what is the meaning of modulus? Modulus means plus x and minus x. So it is plus x less than a, minus x less than a. Plus x less than a, I keep it as such. Whereas minus x less than a, what do? I take it as x greater than minus a. The same thing, I write it in a different way. Okay. Similarly, modulus of x greater than a. How do I write modulus of x? I write it as plus x minus x plus x greater than a minus x greater than a. Plus x greater than a, I keep it as such. But minus x greater than a, what do? I do it as x less than minus a. Okay, for modulus of x less than a, what is my function? The function f of x is 1. Okay, and for the second part, where modulus of x greater than a, my function is f of x is equal to 0. Okay, now I will draw a diagram for this to make it even more easier. So what is my limit in the formula? In the formula, my limit is minus infinity to infinity. So minus infinity to infinity. I mark a center point 0. Okay, so what is there here? X less than a, x greater than minus a. So first I will mark a and minus a. A is plus a, so I mark it here. Minus a is in the negative side, so I mark it here. Okay, so for x less than a, so where is x less than a? So less than a is x is less than this part. Okay, whereas x greater than minus a, so greater than minus a is this part. So x less than a, x greater than minus a is this part. Okay, for this part, the function is f of x is equal to 1. What is next? X greater than a. So which is x greater than a? X greater than a is this part. Okay, for this part, f of x is equal to 0. I have one more, x less than minus a. So x less than minus a is this part. So the function f of x is here. Okay, so now I will write the formula. I will rechange the limit and I will write it. Okay, so how do I change the limit? Minus infinity, see here, minus infinity to plus infinity, I am rechanging it. Okay, I write it as minus infinity to a f of x e power isx dx plus minus a to a. So minus a to a f of x e power isx dx plus, what's the last part? The last part is a to infinity. So a to infinity f of x e power isx dx. Okay, so for the first part, minus infinity to minus a, what is the function? F of x is 0. So here it is 0. The second part, minus a to a, what is the function? The function is 1. So it is 1. The last part, a to infinity, my function is 0. So this is 0. Okay, so 0 into anything is going to be 0. So this part will get cancelled. So here also 0 into anything is going to be 0. So this part will get cancelled. So what is remaining? Minus a to a. Okay, so what is my value of f of x? Value of f of x is 1 e to the power isx dx. Okay, now I need to solve this. function of e to the power ax dx. How is it written? It is e to the power ax by a. Okay, e to the power ax by a. So instead of a, what I have here? I have is. So how do I integrate this? It becomes e to the power isx by, instead of a, I have is here. So it is is, and the limit is a and minus a. Fine. Now I substitute the upper limit minus the lower limit. So it becomes, where and all I have x, I substitute the upper limit, and where I have x, I substitute the lower limit. So it is upper limit minus the lower limit. So here it becomes I yes a minus, so this is my upper limit minus, what is my lower limit? My lower limit is minus a. So it is e to the power is into minus a. Fine. I have a common denominator which is is. So how do I write this? I write this as e to the power isa minus e to the power minus isa by is. Clear? Okay. So e to the power ix. How is it written? It is written as cos x plus I sin x. Similarly, e to the power minus ix. How is it written? It is written as cos x minus I sin x. Okay, so now I use this here. So e to the power isa. Instead of x, I have sa here. So it is written as cos as plus I sin as. Fine. Similarly, minus of, how is e to the power minus isa written? It is written as cos as minus I sin as, and there is a common denominator and it is is. Okay, so now what do I do? Cos as plus I sin as. I take this minus inside, so it becomes minus cos as plus, minus to minus is plus, I sin as. There is a common denominator again and it is is. Okay, so cos as and minus cos as plus cos as and minus cos as will get cancelled, and I have I sin as, it is same, so I add, it becomes 2I sin as by is. Okay, so this I and I will get cancelled. So what will be my f of s? My f of s will be 2 sine as by s. Clear? Now f of s, we found f of s. Okay, so now we will go to the second part. So what is the second part? And hence evaluate this particular integral 0 to infinity sin x by x dx. So we'll find this out. So what we have to find out? We have to find out now we have to do the second part. So what is the second part? And hence evaluate integral 0 to infinity sin x by x dx. Okay, so to do this, we will use the second formula. So what we have to evaluate? We have to evaluate integral 0 to infinity sin x by x dx. Okay, so to do this, we will use the second formula. So what is the second formula? This is the inverse Fourier transform formula. F of x is equal to 1 by 2 pi integral minus infinity to infinity f of s e to the power minus is x ds. Okay, so now I know what is f of s. So f of x is equal to 1 by 2 pi minus infinity to infinity. So what is f of s? 2 sine as by s e to the power minus isx ds. Okay, so now we will compare this. So here I have 1 by 2 pi, whereas here I don't have 1 by 2 pi. It is minus infinity to infinity, whereas this is 0 to infinity. Okay, I have sine x by x. I have something in terms of sine. Then I have e to the power minus isx, whereas here I don't have e to the power minus isx. So what I should do, I should make this e to the power term vanish. So to make this vanish, what do? I put x is equal to 0. So if I put x is equal to 0, what happens? This becomes f of 0 is equal to 1 by 2 pi minus infinity to infinity 2 sine as by s, okay, e to the power minus is into 0 ds. So we clearly know e to the power 0 is 1. So what happens? Then what do? I cancel this 2 and this 2. So it becomes f of 0 is equal to 1 by pi minus infinity to infinity sine as by s ds. Clear? Now, what am I going to do? I'm going to take this by this side. So it becomes minus infinity to infinity sine as by s ds is going to be f of 0 into pi. Okay. So the function we know in the function, the question it is given that what is f of x? We know what is f of x from the question. F of x is 1 for x modulus of x less than a. Okay, so for plus x less than a and minus x greater than a, the value is 1. So I have to find out at x is equal to 0, what is the value? At x is equal to 0, the f of x value is 1. Okay, so I substitute this here. Okay, from my diagram, okay, this diagram, I hope you remember this. Minus infinity to infinity, minus a, 0 plus a. Okay, so this part, f of x is equal to 1. So f of 0 is 1. So from this, I come to know that my f of 0 is 1. So minus infinity to infinity, sine as by s ds is equal to pi. Okay, so what is my question? In my question, I have to evaluate integral 0 to infinity sine x by x dx. I have to find out. Okay, so now what do you think is the change? Here the limit is minus infinity to infinity, whereas here the limit is 0 to infinity. Okay, so now when the limit is minus infinity to infinity, I can check whether my function is odd or even. Okay, we clearly know that my sine function is an odd function. Okay, in the denominator what I have? I have s. Okay, so s to the power 1. S to the power 1 is also an odd function. If it is s square, it is even. If it is s cube, it is odd. So sine x by s, which is odd by odd, minus by minus becomes plus. So it is an even function. When the function is even, okay, since this particular function is an even function and the integral is minus infinity to infinity, how do I write it? I write it as twice 0 to infinity sine as by s ds is equal to pi. Clear? Now what do? 0 to infinity sine as by s ds is equal to pi by 2. Fine. Now look at this. 0 to infinity. Here also it is 0 to infinity. Here it is sine x by x, whereas here it is sine as by s. So what I have to do? Instead of as, I have to put x. Okay, so now what is the value of s? The value of s is x by a. Fine. Now what is the value of ds? ds is dx by a. Fine. Now what I will do? I will substitute this here. So integral 0 to infinity, instead of sine as, what I should put? As is equal to x. So sine x by, what is the value of s? The value of s is x by a. So x by a into, what is ds? ds is dx by a. So dx by a is equal to pi by 2. So what happens? This x goes on the top, 0 to infinity. Sine x into a by x into dx by a is equal to pi by 2. Okay, so this a and a gets cancelled. So what is remaining? 0 to infinity sine x by x dx is equal to pi by 2. So hence we have found out 0 to infinity sine x by x dx, the value is pi by 2. Hope it is clear. You have any doubts, you can ask me.